Welcome. Today we're going to take a look at using the STEPScope to make better return loss measurements. Return losses is sometimes a challenging measurement to make, especially when you have huge discontinuities, which might happen when you are using 75 ohm DUTs and trying to measure them with 50 ohm systems, or when you have just a section of the response that you really want to use in your measurement. For example, a test DUT here where you might want to measure the return loss going into the integrated circuit and not through the connectors or any other discontinuities. So by using the windowing feature that's new on the STEPScope, we're able to pick off that section of the response, identify it in the time domain version of the impedance profile, and use that to measure return loss. So let's get started. So the measurement I'm going to make is of a small test DUT here, and specifically I'm interested in getting the return loss in the integrated circuit, but to get to it I have to mount it on a board, I have to connect to it. I have a 16-inch cable here I'm going to use. I'm making single-headed measurements, I might point out, so I've terminated the unused input of the differential pair. So I'm going to set my reference plane here at the end of this connector, of the cable, and perform that reference plane calibration, and then make measurements of the return loss. Okay, so to do the reference plane calibration, the first thing I need to do is get access to the calibration tools down here. And I want to calibrate a short, so I'm going to disconnect the DUT and connect a screw in the DUT. A 50 ohm short termination into the cable end and press the calibrate short button. This will allow the STEPScope to capture the response to a short so it can use it in future math operations. Once the calibration to the short is done, it only takes a few seconds, then I can take the short off, and it asks me to put a termination on there. I'm using the calibration or termination kit that we offer from Bitwise, and now I will say calibrate with the termination, and it will learn that response. The result of doing the calibration is to actually make a measurement, and it will make one measurement. Presently it's still connected to the 50 ohm reference termination, therefore the line is going to show me is by definition 50 ohms. But if I take this off and connect it to a DUT, say the DUT I'm interested in, and ask it to run a single measurement, for example, it will measure one input. And I can go in there and zoom in. One of the easiest ways to do that is to use the tools here and just change my time scale maybe out to, say, 3,000 picoseconds, 3 nanoseconds, and it'll show me my response. That's still more than I need, but here I can see the effect of running down the trace, and in fact, if I press run and just let that run, I can actually come in here with my finger and touch a portion of the trace here and see the capacitance of my finger, and as I move it down the trace, you can see working its way down to the IC itself. So that's the TDR response that we're seeing from this system. Once I have a TDR response, the STEPScope then allows me to make a return loss measurement, S11. And here I can run a single measurement and see what the spectrum, the frequency response is of the insertion or return loss. Here we can see it's quite good, almost 20 dB down in this area here. I'm going to go ahead and archive this. This is a straight measurement of the entire response. So I'm going to press download so I have this data available later to be looked at. In fact, I will open this in an Excel spreadsheet so that later I can plot them both up there. Okay, so now that I have this return loss plot of the total response, I can go back to my TDR view and use the windowing feature. So I'm going to turn on windowing and set my cursors here to define the S11 window. And that gives me access to these two cursors, and it will define the window that I'm interested in. Now, what I'm interested in is not the leading edge where I have my cables and connections or the PCB trace. I'm really interested in getting into the chip. So I'm going to set this after the connector to the starting point and set the ending point somewhere down farther, so that I'm basically going to ignore getting onto the test structure through the SMA connectors there. It will set my time for the beginning and ending so that I have the window. And now when I go over to my return loss plot, and it gives me the message that window is being used, I can now press a single response and see the result of the windowed return loss measurement. Now, let's compare this to what we saw before. The easiest way to do that is to download this data also, and also bring this up in the Excel spreadsheet. So here's a comparison of the two data charts. The earlier one with all the response is in orange, and blue is our sort of truncated windowed response. You can see it's not a dramatic difference in this example, although you can see it doesn't have the resonances that are present in this response, which is caused by that initial bump that we saw in the TDR right here in the beginning. So this is an example of how to use the windowed feature to get a better look at the return loss of exactly your device. We hope this measurement example has been helpful. Using windowing is particularly beneficial when you're working with large discontinuities in your test structures. For example, sometimes it's inevitable when adapting to BNC connectors or 75 ohm BNC connectors when making those types of measurements, and being able to window them out is an effective way to make a measurement of your real system. If you have any other questions or would like to see other videos in this series, feel free to drop us a note with your questions.